it as a fraction or as a decimal. If you like, and if they ask you, you can always write it as a percentage. So I could say 1/6. I could say 0.16 with the 6 repeating, or I could say 16.7%. All three answers are acceptable when they ask for probability. Decimals, fractions, and percentages. Sometimes they calculate probability with area, strangely enough. And when you calculate probability with area, your successes are usually the shaded portion of the total area, and then the total area is all the possibility. So in this particular problem, number 3, it says, calculate the geometric probability. What's the likelihood of hitting the shaded area with a dart if you throw it at the rectangle? If I look at all of this area, the whole area, I notice that the total is equal to the base of the rectangle, which is 10, times the height of that rectangle, which is 6. So my total is 60. This is the bottom of the fraction that we would use. When I look at the rectangle inside, and I'm going to have to probably make a small guess here, I see this as two different pieces. I see it as, first of all, there is a rectangle in here. That is a 2 by 10 rectangle, which means that for the rectangle, the area is equal to 2 times 10, which is 20. And I also see that there is a triangle. And it looks like the height of that triangle is 2. And I don't know. Oh, up above there's a 4, so it looks like the base is 6. So the area of the triangle is equal to 1/2 the base, which would have been 6, times the height, which would have been 2. So that's 12 divided by 2, or in other words, 6. Pardon me? I sure hope so, since I'm teaching it to you. No joke, I really do. That means that the probability of the shaded area would be equal to the total shadings, which would be 26, out of the total area, which would be 60. And of course, you could simplify this by, after you hit the enter in your calculator, give me a decimal to 2 places, or go math, enter, enter, and it would simplify it for you. So this is 13/30ths as a fraction. And if you were to write it as a decimal, 13 divided by 30 is 0.43 repeating, with the bar over the 3. And if you wrote it as a percentage, if you like to do that, you would write down 43.33%. So I would take any of those last 3 answers. In our last example, sometimes experiments or data is given in a chart. So here's a national survey that was taken measuring the highest level of educational achievement among adults 30 and over. Recently, this calendar year, I looked at the 2010 census, and I was looking for people who earn bachelor's degrees, because in our school we have a program called ABID that helps kids move towards college. My own kids are moving towards that age. And only 29% of our country do people have bachelor's degrees. 9% have master's, and 3% have doctoral degrees. 29, 9, and 3. That's as of the 2010 census for all age-eligible adults, meaning, generally speaking, you finish a bachelor's degree in 4 years, so this is like 22-year-olds and older. 29%. Yes. Interesting, isn't it? The first question is, what's the probability that somebody chosen at random is going to be a man?
785.
So when we look at this, we look at the men, And here are the men category right here. The total for the men is 1570. So I know that when I'm talking about this, the success is making sure you find that you got a man. So this is, and you can ask Fiore about that. That's on the recording. 1570. And then divided by the total, which is 3172. And again, on your calculator, you can simplify that if you want to. The second question is, what's the likelihood that the highest level of education completed by a randomly chosen person is going to be a bachelor's degree? So now you look for bachelor's degree. And if I look for bachelor's degrees, those are these right here. This is the total. So the bachelor's degrees total is 1,002. Those are your successes out of all the people that were surveyed. So that's 1,002 over 3172. And I don't really have room to simplify it here, but you can easily do that again on your calculator. Just hit 1,002 divided by 3172, and then math, enter, enter. Don't worry about it for right now. Part C says, what's the likelihood or probability that a randomly chosen woman earned a bachelor's degree or a graduate degree? So all we care about here is the randomly chosen woman, nothing else. Not the total number of people, but the total number of women. So when you talk about that, that's a little bit different. So when you're talking about the randomly chosen women, that's the number 1602. That means that the bottom of my fraction for this one will be 1602. And now I want to see which of those women earned a bachelor's degree or a graduate degree. So here's the bachelor's degree for the women and the graduate degree for the women. So I totaled those two up, 539 and 377. And how many did you get?
916. 16.
How many think 16? Okay, I'm going to go with the 916.
Oh.
916. And then the last one says, what's the probability that a randomly chosen person whose highest level of education is high school is a man? So now all you care about is the men who are high school students, period. So really all I'm looking at for this category is this row right here. So when I'm looking at that row, I want the men out of that row, 305, out of the total number of people who got high school degrees, which were 537. So the thing that's really important is you need to make sure that you're reading the question carefully so you have the correct numbers for the totals and the successes.